the basic concept of alternating series and alternating series test. So alternating series is a series of terms that are alternatively positive and negative. So there are two examples. So in the first example, I have 1 minus 1/2 plus 1/3 minus 1/4 plus 1/5 minus 1/6, so on and so forth. So do you see that the plus and minus, they are alternating? So this is an alternating series. But when you express that as a sum, how do you express the positive and negative? That is a characteristic of alternating series. So you have to look at this part. So we have a -1 raised to n minus 1 power. So when you write like that, you are creating an alternating series. That is the only way to make the plus minus alternate. All right, so we have, and then other than that, we have 1 divided by n. Do you see that the denominator has an increment of 1? That's why the series is 1 divided by n. And then the next one, we have -1/2 plus 2/3 minus 3/4, the minus plus, minus plus, minus plus. If you want to do a minus plus, if you want to follow this pattern, then on the exponent of -1, you have to use n instead of n minus 1. Do you see the red n over there? So if you use a red n, then the plus and minus starts with a minus and then a plus, minus, plus. If you do a -1, then you will be a plus, minus, plus, minus, plus, minus. Okay, what is an alternating series? So let me give you a picture that explains the alternating series. So we have dots here. So we have some dots above the x-axis and some dots below the x-axis. So the first dot is above, the second dot is below, the next dot is above, the next dot is below. So this is alternating. So that means the terms, they are alternating between positive and negative. Positive is above the x-axis, negative is below the x-axis. So it's like a ball bouncing between positive and negative. So do you see that a ball? Do you see the pink path is bouncing between the positive and negative? This is called an alternating series. And then the biggest characteristic of alternating series is you have a -1 as a base, and then you raise to some power. The power there is an n in it. That is the only way to create a plus minus or minus plus pattern. So for alternating series test, we have an alternating series. We have to prove two things. Number one, bn plus 1 must be less than or equal to bn for all n. And then number two, the bn, the limit of bn is equal to 0. So for the first one, the n plus 1 is less than or equal to bn. So for the bn plus 1 less than or equal to bn, here is how I call them. The bn, I call it a current term. And the n plus 1, I call it the next term. So we have to show that the next term is less than the current term, and then all the b's, not all the b's, the limit as n approaches to 0 of bn is equal to 0. So let's break down this language, right? So let's break down this language using the two examples up above. So the first one that I gave you is I gave you a 1 and then a 1/2 and then a 1/3, right? So to understand how the alternating series test works, we have to omit all the positive and negative. So I am not going to do any sign. I will just write 1, 1/2, 1/3, 1/4, 1/5, 1/6. Don't let the sign fool you. So if you put the sign in there, you will never be able to understand how this test works. So let's check number one. The next term is less than or equal to the current term, right? So do we agree that we can draw inequality symbol like this? The next term is always less than or equal to the current term. So let's don't do the plus. Do we agree that the inequality is satisfied? The next term is less than or equal to the current term. And then that is number one. And then number two, the limit as n approaches to infinity of bn equals to 0. What does that mean? Now, I have to talk about the series when you look all the way to the right. So we have 1, 1/2, 1/3, 1/4, 1/5, 1/6. If this pattern keeps on going, what do you expect to see all the way on the right? So if the pattern keeps going, since the next number is less than the previous number, as n approaches to infinity, that means you are looking for the terms on the right hand side. They want that to be a 0. Why? because you are trying to add up this sequence, right? So when you add up the sequence, you want the sum to be convergence. You want the sum equals to a real number. The only way to get it is the last couple terms must be all 0. So when the last couple term is all 0, that's why we have to prove that the limit of Bn is equals to 0. You are adding up a bunch of numbers. When n gets really, really big, those terms, not just one term, those terms, when n gets big, they are all 0 or they are very close to 0, which means the sum is determined by the first couple terms, probably right there. The sum is determined by the first couple terms, because as you add more zeros to the sum, that doesn't change anything. So therefore, the sum is determined by the first couple terms, and therefore the sum is just equals to a real number. As a result, the series is convergence. All right. What if the 1 and 2, they are not satisfied? Then let's take a look at the next one. So the next one, what do I have for you? The next one, I have a 1/2, and then 2/3, and then 3/4, and then 4/5, and then 5/6, and then 6/7. 6/7. Can we say that the next term is less than or equal to the current term? Can we say that? Can we say 2/3 is less than 1/2? The answer is no. This is not true, right? Do you see the orange inequality symbol? Is that true or not? So 1/2 is equals to 0.5, right? So that is equals to 0.5, and then 2/3 is equals to 0.67, and then 3/4 is equals to 0.75. There is no way that you can link them using this symbol. There is no way to say that 0.5 is greater than 0.6. No way to say 0.6 is greater than 0.75. So that means the first condition is not satisfied. There is no way to use that inequality symbol in there. So let's just cross this out. So let's just cross this out. There is no way to say that they are satisfied. So number 1 is fail. So now, without looking at the positive and negative, look at this pattern for me. So these numbers are getting bigger and bigger, right? So 4 divided by 5 is equals to 0.8, and then you do 5 divided by 6, that is equals to 0.83, and then 6 divided by 7, that is equals to 0.86. So as you keep going, do we agree that the numbers are getting bigger and bigger? The numbers are getting bigger and bigger as n approaches to infinity. So therefore, if you find the limit as n approaches to infinity, Bn, what is Bn? Bn is you just look at the value only. You don't care about the plus or minus. If I just look at the value only, that's why I take out all the plus and minus out. So if you just look at those quantity, the limit as n approaches to infinity of Bn, this is just equals to infinity. As a result, the sum is going to be very big. Therefore, the sequence is divergence. Because you are adding up big numbers as you look all the way to the right. You are adding up big numbers to a sum. The sum is going to become really, 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 really big. As a result, the series is convergent. So that is the basic concept of alternating series. If you think my instruction is helpful, please like, subscribe, and share. I appreciate your help. What do you think about this? Let me know in the comment section below. In the next video, I will use a few series to show you the application of the alternating series test. I will see you all in the next video. Signing off for now.